Hello, I'm Sujata from CBSE NEET JEE Chemistry.in. In this video, we will learn how to apply the concept of nucleophilic substitution reactions undergone by vinyl halides. You will see this question and its variations in many exams, and understanding this will give you a definite advantage. Nucleophilic displacement on a vinyl halide. By now you should be very sure about what is an allyl halide, what is a vinyl halide. The halogen is bonded to a carbon-carbon double bond, sp2 carbon atom. Okay, may be represented as, the mechanism has been displayed here. You get this intermediate which will give you the final product, substituted product, and the halogen is lost as the halide ion. Right? Now the question is, which of the following vinyl halide is expected to follow this mechanism? Okay? Now, so you must be clear about the fact that this is just a general representation. So some groups are attached here. What are these groups attached are what is displayed in these various options. In option A, the two groups attached on this carbon atom are two hydrogens. Okay? So hydrogen, H and Br. Alright, it is a vinyl bromide. Fine. The hydrogen does not play any specific role in order to increase the density or decrease electron density, as a result of which let's analyze all the options. Okay. Let's move on to option B. On this carbon atom, this carbon atom, the two groups attached are a hydrogen and a methyl group. So you have a methyl group and a hydrogen. Now methyl group has a specific role to play. You know that methyl group is an electron donating group, a positive inductive effect group, right? So it pushes electrons towards this carbon atom. Now look at the intermediate that has been displayed here. The nucleophile is bonded not to this carbon atom, it is bonded to this carbon atom. Okay? The nucleophile is bonded to this carbon atom. In other words, this carbon atom is acquiring a positive charge. Alright? And this carbon atom is acquiring a negative charge. So a carb anion is produced. Alright? So you have a methyl group. If a methyl group is attached here, it will release electrons towards this carbon atom. Fine. And you notice that in this intermediate, there is no pi bond. The pi bond, so before the nucleophile got attached, why did the nucleophile get attached to this carbon atom? Because this carbon atom was electron deficient. Why did this carbon atom attain electron deficiency? Because the original pi bond which was holding these two carbon atoms is now shifted towards this carbon atom. Right? Therefore, this carbon atom has lost one of its bonds, acquired a positive charge, and the nucleophile has got attached to it. So that should be the understanding from the representation here. Now, imagine a methyl group attached here. What does the methyl group do? The methyl group makes this carbon atom more electron rich by pushing electrons towards it. As a result of which, there is no way that this pi bond will move to this carbon atom, because this carbon atom has been gaining electrons from the methyl group. So this carbon atom will not acquire a negative charge. So this group is ruled, this option is ruled out. Look at the next option. You have two methyl groups, CH3, bonded to this carbon atom. Two electron releasing methyl groups, which will ensure that this carbon atom is extremely electron rich. Right? Now, so there's no way that the pi bond will shift to this carbon atom. So what you've got to understand and analyze from this discussion is that electron releasing groups, right? The presence of electron releasing groups will make this carbon atom electron rich. As a result of which, this pi bond will not get bonded to this, will not shift to this electron rich carbon atom. Right? In other words, you want electron withdrawing groups to be present on this carbon atom, which will pull electrons towards itself and pull the pi bond towards this carbon atom. And that is what is represented in option D. You have two fluorine atoms on this carbon atom. Fluorine is a very strong electron withdrawing group, right? Double bond CHBr. So final option D would result in this intermediate stable carbanion. A very stable carbanion is produced due to the presence of these electron withdrawing fluorine atoms on this carbon atom, resulting in the final product. Okay, so let's write down the sequence of reactions with the last option. You have C, F, F, okay, double bond, CH, and you have a Br. Alright, this is the alkene, last option. Fine. Now let's see what happens. Okay, let's analyze the formation of the carbanion first. The two fluorine atoms, being electron withdrawing, will pull electrons towards itself, making this carbon atom highly electron deficient, as a result of which the pi bond will shift towards this carbon atom, making this carbon atom acquire a partial positive charge. So what do you get here? C, F, F, single bond. Now this has a negative charge, right? And you have a CH, Br, CH, Br, and this carbon atom has acquired a positive charge. Now the nucleophile will be attracted towards this positive carbon to give you the expected intermediate FCF with a minus charge here, single bond, CH or CBr, H, and the nucleophile. Okay, you get this intermediate, and the final product would be the loss of this bromide ion and resulting in, and this negative charge coming up here. You have two electrons here. The final step would be restoring the double bond, C, F, F, double bond, C, H, and nucleophile, plus Br minus. The Br minus is lost. Alright, so this is a sequence of reactions undergone by this particular alkyl halide, alright, and the presence of electron withdrawing groups will stabilize the carbanion more effectively, as a result of which option D would correspond to whatever mechanism has been displayed here. So option D is the correct answer. We have over 230 videos with in-depth explanation of concepts in an easy and lucid manner in our organic chemistry course. Moreover, we have close to 400 videos of solutions to every kind of question that can be asked in any exam. Click the link in our description below to check out our course. Subscribe to our channel to regularly get new content to help you score high marks in chemistry.